This is Geometry, Section 10.2, Areas of Trapezoids, Kites, and Rhombuses. So, we're starting with a trapezoid. What do we know about a trapezoid? Well, we know it has four sides, and we know that one pair of sides has to be parallel. So, in this example, this side would be parallel to this side. So, to find the area, we already know how to find the area of triangles and rectangles and parallelograms. So if I look at this trapezoid, I could find the area by just breaking it into two triangles. So this triangle right here, this triangle right here, and then this rectangle right here. So if I find the area of one of those triangles, we know the formula for area of a triangle is 1/2 times base times height. So it would be 1/2 times, I need to figure out what this base is, and this base. So if I know that this is 16, this piece right here, then this piece from here to here has to be 16. If this whole thing that it tells me right here is 20, then there's 4 left over after I take away this chunk of 16. So if I split that evenly between these two sides, each of these sides would be 2. So 2 plus 16 plus 2 adds up to the whole thing, which is 20. So then my base would be 2. My height would be 12. So 1/2 times 2 is 1, times 12 is 12. So area of each triangle would be 12, but there's 2 of them. So I would add that together. So area of the trapezoid is going to equal 12 plus 12 plus whatever the area of this rectangle is. Well, we know this piece is 16. This is 12. 16 times 12 gives us 192. So when we add all of that together, we get that the total area is 216. Okay, so we just found the area of the trapezoid by breaking it into triangles and a rectangle. Okay, there is an easier way to do it. There's a formula that takes all of this into account, breaking it into triangles and a rectangle and then adding it all together. So this is the formula. Area of a trapezoid equals 1/2 times the height of the trapezoid times one of the bases plus the other base. So these are the bases. These are the sides that are parallel to each other, so the top and the bottom. And then the height has to be perpendicular to both bases. Okay, so usually it's drawn in for us, sometimes it's not, sometimes we have to find it. So the height, just like with a triangle, needs to be perpendicular to the bases, and then B1 and B2 are just the two bases. So for example, B1 and B2, B1, B2 would be 7 and 19 for this trapezoid, and the height, it gives it to us right here, is 9. So plugging all that in the formula, 1/2 times 9 times 7 plus, don't forget that this is a plus, it's not just multiplying everything together, we have to add the two bases together. So 7 plus 19 is 26, and then times 9 times 1/2. If we multiply all of that together, we get 117 meters squared. Remember to include your units. All right, for the next one, same thing. 1/2 times our height, which is now 12, times our two bases added together. 16 plus 10 is 26. Multiply all that together, we get 156 feet squared. This one is a little bit different. It gives us the area now, and it gives us both bases, and it says we want to find the height. So let's write out the formula. 1/2, area equals 1/2 times the height times base 1 plus base 2. We're going to fill in all of the pieces that we know, including the area. We know that the area is 154, so I'm going to fill that in right here. So 154 equals 1/2 times, I don't know what the height is, that's what I'm trying to find, so I leave that as h. And then B1 plus B2, so 8 plus 14. 8 plus 14 is 22. So then it's 1/2 times, I'm just going to reorder this so that the h is over here. 1/2 times 22 equals 154. Half of 22 is 11. So 11 times h equals 154. And then we would just divide by 11 to find h, which is going to equal 14. So our height would equal 14 centimeters. All right, so that's trapezoids. On the back of the page, kites and rhombuses. So what do we know about a kite? Well, a kite also has four sides. It looks like this. We've got two sides that are the same right next to each other, and then the other two sides are the same. If we draw on the diagonals of a kite, we also know that they are perpendicular. And then we also know that angles across from each other in between the non-congruent sides are going to be congruent to each other. So this angle would be congruent to this angle, but the angle at the top would not be the same as the one on the bottom. For a rhombus, it's similar. It's got 4 sides, but now all the sides are the same. So diagonals of a rhombus are also perpendicular because everything is the same. So it's got 4 congruent sides, diagonals perpendicular, and these angles would be the same, these angles would be the same. So finding the area of a kite and a rhombus, fortunately, they have the same formula. So it's based on their diagonals that we know are perpendicular for both of them. So the area for the formula for the area of a kite and a rhombus is going to be 1/2 times the first diagonal times the second diagonal. So these are diagonals, the lengths of the diagonals. Okay, so obviously we need to know what the lengths of the diagonals are in order to use this formula. Sometimes it's going to be given, sometimes it's not. Okay, so 1/2 d1 d2. Okay, so if we look at this kite right here, we know these 2 sides are the same, these 2 sides are the same. It gives us certain pieces of the diagonal. So this we could call diagonal 1 from here to here. So it says this piece is 2, this piece is 6, but I want the entire piece. So I just add those together. 2 plus 6 is 8. This, it gives me 3 is right here since I'm going from this half to this half, and this is symmetric this way. So this triangle is the same thing as this triangle. It's symmetric, which means this piece has to be the same thing as this piece. So we've got 3 and 3, so this whole diagonal, or diagonal 2, would be 3 plus 3, which is 6. So now I'm just going to take 1/2 times 8 times 6. 8 times 6 is 48, and half of that is 24. For this one over here, I've got this piece is 4, and these are actually marked for me. So when I have a rhombus, not only are the diagonals perpendicular, but they also cut each other in half because it's a special kind of parallelogram. They bisect each other. So if this piece is 4, this piece is 4, so this entire diagonal would be 8. I need to find this piece and this piece, though. I know they're both the same, but I don't know what each one is. However, I do have a right triangle right here, and it tells me that each of these pieces is 5. So I have 4 of the same right triangle, so if I find this piece, then I've also found this piece. This is a right triangle. We have 2 sides. We're missing 1. So whenever we have that, we use the Pythagorean theorem. So we'll call this x for right now. So 4 and x are the legs. 5 is the hypotenuse. So I set it up like this. X squared plus 4 squared equals 5 squared. 4 squared is 16. 5 squared is 25. X squared plus 16 equals 25. So I would move the 16 over. 25 minus 16 is 9. And then I take the square root of that, and I get 3. So this piece is 3. This piece is 3, which means this diagonal going this way is 6. Again, just like this one, 3 plus 3 is 6. So when I plug it in the formula, 1/2 times 6 times 8, we end up with the exact same thing we had over here. So our final answer is also going to be 24.